sometimes there are vacation rooms. But there are some space.
So it's the vacation like house in
Denmark, that's only rents in few homes in Germany, Sweden. But the company I work with, it's called Old Vacation Homes. All these are sub-companies. That's in two families. They have all these companies have vacation homes are
they open to anyone who wants to join us.
you can just like Airbnb, you can just come outside and book.
Just someone like equal someone.
So that website also someone needs patience.
So, hey guys,
Just
I think we're
request
slowly gonna get started.
begin.
Super. So I guess you're already fairly familiar with the practicalities, but welcome to a new meetup after quite some time now. I'm so happy to see all of you guys here, and I hope that this is the first event in a kind of monthly event. The field is definitely very, very vibrant and full of innovation. And I'm very happy to see a lot of familiar faces from before, and I hope you got a chance to meet new people working from different companies. I mean, the idea is that you mingle. And around 7, we're going to have some pizza coming up, so the conversations can continue. But for now, if you need a toilet, there's a toilet after you go down the stairs on the other side. You take a right-hand turn. I hope you already got to enjoy the free booze and the sodas and the snacks. If you need to drop your bags or something like that, there's also a room next door that you can do it. But otherwise, welcome to the Leo Innovation Lab. I'm going to say a few words about my company that allowed me to do this and kind of provided some of the funding for these activities. So my name is Radu. I've been just a few months with Leo Pharma. So I can't really walk you through the history. I think we're learning here together. But Leo Pharma is one of the historical pharma companies in Denmark. So they've had products since 1912, and of course, more complex products, and this product line I'm not really familiar with, to be honest. But what we're doing today, we want to become a leader in medical dermatology. So that's why digital actually plays a huge role. So as most companies, we're looking for delivering double-digit growth. If you work for a corporation, you probably have heard something along these lines. What does it mean? It means that you have to release a drug every 2 to 3 years. That's the ambition that we have. And if you've heard about, delivering new drugs, you know that this is a very tough thing. We also put our target on ourselves to be, for these drugs to be first in class or best in class therapies. So that means that we can't just come with, a different ointment, formulated differently, and then it's one of these 2-3 years releases. So we have to build a leading portfolio and rank as one of the top companies in medical dermatology. And if you know about pharma, I mean, we have around 6,000 employees, and this is nothing. Big pharma has 60,000 employees. So we try to carve our space in medical dermatology. But of course, this means that we have to build a team, and this is a team that was built by trolls. So he's on the top left side, and a lot of this team, Paul Jacobs and Catalina and other people, actually started here in the Innovation Lab, which is a place where ideas get generated and things happen. But trolls took the ideas that the Innovation Lab had, which is a place for experimentation, the ones that you're sitting in today, in the city center, where all the cool kids are doing stuff, and brought it back into the corporation. And that's where we built a team. And we have a couple of people here, like Marcin, who's also in there, Matthias, who's online, and other people. By the way, this event is going to be streamed online, and there's a camera there that kind of points towards the presenters. And so I hope you're okay. If you want to keep out of the camera, just move a little bit further back. Yeah. So the team that I'm in, that is always hiring, so keep an eye on Leo Pharma and look at the R&D, data and analytics, because there are many teams within pharma, has a big ambition. So I won't say anymore, and I think I can invite our guest speakers for today that should introduce themselves.
Shall we? We will. Yes.
You control? I control.
You control. All right. Yes, I'm Jan. This is Darius. We come from Banking Circle, and today we will try to show you what we have been doing since we started in Banking Circle, and we will go through an introduction to Banking Circle, say a little bit of what we're doing, and after that we'll present the data platform that we're building, and we have some interesting do's and don'ts in that process, and then afterwards we have room for some questions. So let's take the introduction. Darius?
Yes, that's me on the left side. Nerdy about technology for a long time. I think I started in high school with the C and C++. Originally from Romania, I moved over here to study, did my master's at the IT University of Copenhagen. And then before joining Banking Circle, I was at Nordea as a graduate, moving around different positions and getting closer and closer to data. Towards the end, realizing that data engineering is really cool. And then I joined Banking Circle about a year and a half ago and had a lot of fun with data engineering.
Yes, I'm Jan, and that is actually me. I finished my master at DTU, and then I have been in a couple of companies before I ended in Banking Circle. And the data engineering team started in Banking Circle as it is today in November 2019. We are today 8 people, I think 6 nationalities right now.
Yes.
Yeah, around that number.
6 or 7.
Yeah. Yes.
Yes.
All right. Let me try to say a little bit of who is Banking Circle. What we're building is financial infrastructure. And when money needs to be going from one bank account to another bank account, multiple banks are involved in that process, and every step in that process will add some cost to it, will add some fees if it's a cross-border payment, and will add some complexity. What Banking Circle is building is an infrastructure that can handle this process, which make it simple and fast at a low cost. And of course, there's included security and the compliance that is needed. The company started as a Saxo payment company in 2015. In 2018, we got renamed and got equity as a financial partner, and the name is Banking Circle. In 2020, we got a banking license, and early 2021, we transitioned to 100% cloud-based technology. Our headquarters is in Luxembourg. We also have companies in UK, Germany, Netherlands, and Denmark, and the majority of the IT development is done in Denmark.
Yes.
And a little bit of our growth. We are processing more than 6% of the European e-commerce transfer, money transfer. We have more than 117 financial industries clients, and we are more than 350 employees in total. And we actually have hired more than 100 people in 2021.
And to put that into perspective, when I joined a year and a half ago, I think we just hit the 200 mark, and now we're very close to doubling the size. So
Yeah.
The growth is steep.
That is steep, exactly.
And it's exciting.
Very much. Yes, but today we're going to talk about the platform. This is a very high-level architecture drawing of our platform. The main component here is Databricks, and we are also adapting the Delta Lake approach. We have source system coming in here. Some of them are batch extracted, but we also have a service bus, which on top of that consumes the messages that is coming within seconds. Function is picking them up, placing them in our Delta Lake area, Bronx. And for our batch jobs, Databricks is taking care of that, placing them the same location. In the silver layer, we have some transition or transformations going on. And then we present it in the gold layer as a data model that can be used from Power BI, going through Databricks, and we also expose our data models in a SQL database. Our consumer are mainly using Power BI, but some of them actually have access to a Databricks SQL area where they can extract data. And of course, some of them has also access to a SQL database. That is our core architecture of our data platform that we will be talking about today.
Yes.
Yeah.
Is it time to take the first deep dive?
I think it is. Go ahead.
Cool. So now we're going to get a little bit nerdy and dive deep into some details. And first thing, we want to tell a little bit about how we actually develop and then how we deploy our code to Databricks. Our main development environment is VS Code on a local machine. What we try to do is to apply software engineering practices. So we stay away as much as possible from the Databricks notebooks, as tempting as they are. But basically, we want to have a Python library that is then able to be deployed over on Databricks clusters, and that should do all the work for us. So in practice, what it means is that we sit on VS Code, and then we're going to most likely have a extract class and a transform class and a load class. And the extract and the load are normally quite simple because they just read and then write somewhere. But then in the transform, there's actually a lot of things that are happening. There's some joins or mapping or whatever business logic we have to apply. And that's where we apply a lot of our unit testing to make sure that it actually behaves as we want it. But unit testing is not sufficient. So what we do also want to put them all together and then test it all the way through. And that's where we actually move over into Databricks and see how they behave. So we apply the regular software engineering flow. So everything goes through pull requests and master branch. But then in our CI/CD pipeline, we have two main stages. In the CI stage, we build our Python library, and then we push it to something called Azure Artifacts, which is Azure's version of Pipeline. And then that library will get a build number that's equal to the build version that's running from the CI/CD. It looks like this. It's just like that's our versioning as it goes on the cluster. Then when we move over into the CD and we actually want to put it on the different environments, we have three things that we have to deploy. First of all, we have a long-running cluster. It's an all-purpose cluster, something that runs and it's just there. And we deploy our library on a specific version. Then we also have a Python script that triggers the library and actually does all the work. And that one is saved into DBFS over here. And then the third one is our Databricks job. And in this case, what we say is, please run on this specific cluster, and then please trigger this specific Python script that's at that location on DBFS. Now, for us, this has worked very well to start with. First of all, because we could replicate the deployments from one environment to another, and then we didn't have to think that much about like, okay, how we deploy, how we get the code, and we could just focus a lot on making a good framework and then just have a lot of reusable pieces in the different data pipelines. And now we're starting to have more and more jobs there, so we're hitting into some issues. One of the issues is that we have this long-running cluster that's shared between multiple jobs. So this can lead to the situation if we actually have a job that messes up with the Spark driver, that I know there's some problems with garbage collection or uses too much RAM or whatever, that has the potential to affect the other jobs, basically taking all the other jobs running on the same cluster down. So we're investigating that, basically to use job clusters, so ephemeral clusters that just spin up and then we kill them afterwards instead. And we have 2 experts over here that have done a lot of work. You can catch them, 2 of my colleagues. Yes. And then another thing that has worked very well for us is the fact that we have an IT operations department, because we work in the finance world. So the people that build an application are not the people that actually run it and deploy it in production. And a lot of the knowledge and expertise on Databricks are basically with the people that build all these data pipelines. And our collaboration has really worked well, or has improved as we automated all our deliveries with the pipeline, because then instead of them focusing like, okay, where do I need to put this library, or what do I need to do with this, they're more focused like, I have this job, this needs to run, if something fails, how do I restart it, how do I react to it, and then if there's something else that fails, then we get together and we collaborate on fixing it. I see a question.
Yes,
Can we
do you have questions?
Can we wait until the end with the questions? Yes. And then we can go back to slides back and forth. Good. Then we also want to talk a little bit about how we do our monitoring. Because we have our jobs running here in Databricks, and that's fine. But then you also want to see how the jobs behave. And I don't know if you've ever been on a Databricks cluster logs. Trying to find something in there is really, really difficult. Trying to query those logs is next to impossible. Or if somebody has a good solution for it, please come afterwards and let me know what you've done. I'm very curious. But what we've done is that we've actually taken the application logs and we're pushing them into something called App Insights. And I don't have a good definition for App Insights, but I just see it as a big database for logs that Azure provides. And then they put some functionality on top of it. So that's coming from our Python code. We push it over there, and we're using the regular logging library that Python has, so nothing too fancy. We just have an additional handler that's added. We push our logs in there, but then we also want to get them out. And we don't necessarily want to always go to a specific window, something that's outside of our development workflow. So what we've done is that we've actually connected Power BI into that application insights, because it connects seamlessly. And then we've made a dashboard like the one you see up here, which is not fancy at all. It's super simple, but basically it allows you to see, well, you can filter on days, or you can filter on the log levels. You also have the different jobs, and then the different pipelines that are inside the jobs, and then you see all the logs over there. So it just gives us a nice overview for everything that we have. And then, because again, we don't want to go to somewhere that's outside of our development workflow, what we've done is that we've taken that Power BI dashboard and we actually put it into a Teams channel in one of the tabs. So now it's together with all the developers are, where we're collaborating, where we're talking about everything. So it's super easy just to have a look at all the time, how is production going, or how are all the other environments going. And then that worked well. And what's also nice about it is that you can connect multiple things to App Insights. So if you have Docker containers, if you have, I don't know, VMs, if you have whatever it is, then you can push your logs there, and they basically get fed into the same dashboard. So that was a big maybe not win, but just like a good pattern, like this works. Good. And then I will get a little bit nerdy about data modeling and something that worked for us, and then we fixed it in a different way, or worked in the beginning, then didn't work, and then we changed it a little bit. But basically, we have two sources on the left side. We have a service bus that pushes messages all the time, streaming once every few seconds, and then we have a database. Good old Oracle databases over here. Then at the end, we have the target table, a single target table, that's supposed to put these data sources together, and we get most of the messages from the top one, while the bottom one just gives us 4 or 5 fields. And then what we did was that we implemented a streaming job. We save all the messages with the Azure functions, as also Jan mentioned earlier. And then we do Databricks streaming into our goal layer, where we parse it from JSON format into our desired Delta Lake model. And then on the bottom, we have batch loads. It's all in Databricks, but we load it on various frequencies. And the idea was that we would have the streaming job and the batch job merge in the same table. And these two pipelines work very well separately. The problem was that once we started putting them together, then there were a lot of concurrency issues. They would basically blow up. And we tried to do some retries to see if we can trick it or do something about it. And then what we ended up with as a solution is that we split up those two tables because we couldn't find anything that works according to our requirements. So what we did was that we just took like all the streaming goes into a table, batch goes into a different table, and then on the consumer side, you need to have something that joins. You just need to explain that to your users. But this also allows us, like it's big tables. It's over 100, around 200 million records, so maybe the join will not be the most effective done in Databricks. So, but it also gives us the opportunity that, okay, now we have two tables, and we want the result of them. We can also join as a third table and put it all together over there, and that should perform a lot better. So takeaway is, don't try to merge into the same table from two different pipelines. That did not work very well for us. And then we have, how much time do we have? We have a little bit of time.
A couple of more time, yeah, right?
Yeah.
Okay.
Cool.
Okay. Should I say something
Yeah,
about
go.
infrastructure? Yeah. We've terraformed all our infrastructure, so it's all infrastructure as code, and we deploy it all with CI/CD pipelines. And that is a pattern that works very well for us. Basically allowed us to deploy to different environments and make sure they're reproducible, and it also allows us to have immutable infrastructure. So if something doesn't behave as we want it, most of the times we're just going to tear it down and build it up from scratch again, unless there's some state, because obviously then you will actually want to keep the state across. But it also made it easy just to, when we had to do fixes, put it in a place, you know, if it works in the dev environment, it will also go and work in the next environments. A fun one that gave us some headaches, Azure functions. Out of the box, they work perfectly. They're really, really good. And when they work, they just save so much time. But the problem is, if you do something more complicated with them, for example, Azure Functions can connect to a SQL database, but we wanted it to connect to an Oracle database. So we had to install our Oracle drivers on the container where the functions are running. And it works. I mean, you can figure it out, how to do a container, how to push it up and everything. But once you get a little bit outside the regular pattern that Microsoft recommends, then you might have to do some debugging to figure out what's working, what doesn't working, if it's breaking, why did it break. And getting logs out of Azure Functions, oh my God, that is a big, big headache. First of all, you need to know where to click. Like there's some specific URLs where you have to go. And then let's say like, oh yes, now I found my URLs, so I'm happy, I know where to look for my logs. But then you discover that the logs are delayed by like 5 minutes most of the time. So you just have some really, really slow feedback loops until you find the problem, fix it, deploy it, check again, and then there's another problem. So it just like goes like that. But I can recommend them, or we can recommend them. It's just
simple tasks.
Yes, debugging is gonna be a steep learning curve. Yes, and then Azure Databricks and Power BI. We started connecting it as it's in the architecture drawing as well to expose the gold layer of the Delta tables, and that works very well. Microsoft is spending a lot of time and effort in both Databricks and Power BI. So there's also some really nice functionality that comes from Power BI and can be like simple-ish stuff that you have your AD user in Power BI that is then propagated all the way down to your Delta table. So it just makes access control super easy throughout the whole platform. And then they're also coming up with different features on how to get data from storage accounts with parallelism, something called Cloud Fetch that we need to look into. Yeah, but that also works well. Some other patterns. Was there anything else?
No, I just want to say that the SQL Server is there on the architecture, and that is not the main feeder into Power BI. It's just there because users are more familiar with the SQL Server. But the main source to Power BI is the Databricks cluster that fetches the data from the global data.
Yes. And I think that was pretty much what we wanted to show and tell today. So now it's time for questions. And then in the meanwhile, you guys can save our emails. They're up there. And the QR codes are for our LinkedIn profiles if you want to get in touch. But now please shoot questions. And you had one in the back.
I have so many.
Okay.
We also have a question from online.
Okay. But he was first. We take the one in the back, and then we take the one online.
Can you elaborate a bit more on, like, so okay, you have this running cluster, where your job is running, potentially also this stream. Well, how do you deploy a new version of your code onto this? When you have like
I'm just going to repeat the question if there's people online. It's basically the question was how we deploy our code to the cluster. So what we do is that we build it as a Python wheel, and then we push that to the artifact repository, Azure Artifacts in this case. So we get different versions of our library. And then we go to the REST API of Databricks, and then we say, please install this specific library with this specific version coming from this repository. And then it gets installed, plus all the dependencies that it needs.
Yeah, but I mean, you have to uninstall the old version of the library.
Yes, yes.
So do you make a new cluster, or do you have your cluster and install the new version and uninstall the old?
No, so the approach we took initially is that we have a cluster that's running there, or maybe we turn it down if it's not used for some hours, and then we want to install a new version. Then we basically uninstall the previous one and install the new one.
And a very quick follow-up. One thing that annoys me a lot is that in order to authenticate with Azure Artifacts, I have to use a personal access token.
Yes. So, for the people online, the question is how we authenticate with Azure Artifacts. And yes, you do need a personal access token, but you can also generate it from a non-person person. So basically a technical user. But yeah, it's not perfect, so it goes into the URL. But also it's safe from a compliance perspective because we don't have access to it. It's only our operations people that take care of it, and they are allowed to see everything. And also the token is restricted to what it can do. It can only download that library.
Delete all the reports.
No. But good questions. And Radu, you had one from online?
Yes, and that was how do you do authentication? How do you authenticate from all the way from Power BI to the actual data source, or how do you handle that?
We handle the authentication. It runs from Power BI and all the way down to the gold layer tables.
And you propagate from the source system all the way to Power BI?
From Power BI all the way down, yes.
So we authenticate with Active Directory users, and then it's the same Active Directory users that are used across the whole technology stack. And then when we authenticate in Power BI, you also have the opportunity to say, please use the user's credentials when accessing the data. So it just pushes all the way down.
All the way to the Databricks.
Again, a good question.
Another question from online. This is Matthias, our colleague. He says, how many use cases Power BI reports are currently using this platform?
So right now, no, I'll let you answer.
How many do we have? We only have 2, right?
Yes.
Yeah.
I think so.
Yeah.
But the longer answer to that is that we started building our data platform now that we want to do everything and then expose and actually use it for something. But it's more or less breaking it up into chunks. We have a reporting use case and then we fulfilled that one, but in that case we had to send some files to some regulators. And now we're getting to the use case where we have a data model that makes sense to business after we've built like quite a few tables and a few data pipelines. And we've exposed it to the in the gold layer, and now we're starting to build up the dashboards in Power BI. So it's still a little bit early in the Power BI journey. Oh wow.
Thanks a lot for the presentation. Nice stuff. Regarding slide 18, it's not a question, but you remember the joins that we did with the string and the batches? There is a very nice argument called the multi-way joins, and it might worth to have a look at it. It's based on the probing approach. A record arrives and it drops to the data that it will hit eventually to a nice partition idea.
Okay.
I will send you the link.
Please do.
Yeah.
Can you put it up on the meetup because then everybody can see it?
Yes.
As a comment, I think comments are open to everybody. Might be that there's more people interested in that pattern.
Yeah, I have a question regarding the testing. So you said you're doing like, testing like local testing, I assume, but also then when you push it, when you do CI, so how do you actually test integration? How do you test if the data pipeline works? So let's say you have data pipeline A and B, you change something in B. How do you make sure before you deploy that it actually works? Do you do it in static, low environments, or do you have like some other good tricks to do that? Especially in Databricks, because we did that and that's painful. So.
I don't think we're going to have a better solution. So I can just explain how we're doing it. First of all, we're trying to keep our pipelines as independent from each other. So we don't have any deep dependencies. It basically goes at maximum, it's from gold to silver and then from bronze to silver and then to gold. And because we can unit test the transformation, we know what comes from the extract and we know what goes to the load. So we can just use kind of that contract between the two different jobs to make sure that we don't break anything downstream. And then in practice, in order to actually see it work, because there's one thing to see the unit test, but other thing, the most simple approach we've taken is like put it up, see if it works. And that's when we might also go in manually in notebooks and see if the code actually behaves as we want it.
And a quick follow-up, when you say contract between these data pipelines, is that just a schema? Because you could change the data model in one of them, like in the upstream one, and then you can have the same contract as a schema, but it's still different. So you still get a different result on the other one. So is that what you're testing in the unit test? So you generate data for different use cases and then running that through as a contract, or is it just a schema?
So we actually use input data frames. We generate our own mock data, or we use some test data that we have available. Thank you.
Thank you. Yeah.
You have mentioned that it was some issues with the shared infrastructure. Would you please elaborate on that?
Yeah, so the question was about the shared infrastructure and the problems we had. And I mean, it basically boils down to the fact that the multiple jobs are running on the same machines, and sometimes one of them can, I don't know, there's a bug in the code, so it just does something that it shouldn't do, and the driver memory explodes. And then you have other jobs that are depending on the same driver. So the driver could be unresponsive for a while. In the meanwhile, the job tries to run, it fails, and yeah, that's not ideal. So That's why it works in the beginning, but then you need to think about how to separate them a little bit.
Right, thank you.
Have you a question?
Yeah, I just didn't catch the data lake. Like, what storage is that? Is that also an Oracle database, or is it like flat files?
The storage account in our architecture.
The data lake, like
Yeah, the data lake. That is a Azure storage account, also called data lake. Yeah.
So is that like a flat file, or is it type of database?
No, it's yeah, more or less you can save everything you want in that one. That is.
Or that's like a service Microsoft.
That is a service from Microsoft. Yes.
Okay.
And then you can adopt the Delta Lake approach, and that's what we have done. Then you save it in Delta files, so they act like a database. Yeah, you get a lot of functionality on top of that, but still it is flat files or Parquet files or that area. Yeah.
Delta.io, that's where Databricks puts up all their docs, and that's the file structure that we're using. So you can go and check it out over there. There's a lot more details.
Thank you. And the lake house approach. Is it also called? Yeah.
You said that the unit tests were not enough. Can you expand a little bit why? I mean, where did you discover? What did you discover that was not enough to have only, unit test? What was extra thing that you had to put on?
Trying to think of a good example. It's a good question. I mean, just to take it simply, when we get secrets, we use DB utils. And then we have a secret scope that connects to an actual Azure Key Vault. And in order to test this type of functionality, we have to put it in actual Databricks. We haven't found a way how to bring a proper Databricks cluster and run locally. So if any of you has done that, then please come and let us know how you did it, because at least I am very curious to hear about how you did it. But it's this type of things that, okay, did I actually have the right extract and the load? Is it the right folders that is connecting to this type of things, just to see it run all the way through?
You and then after we, yeah.
Could you give a few examples that sort of were enabled by your new data platform? That things that weren't possible before. I don't know, just more like use cases again. You mentioned a few requirements, for instance, that forced you to write your pipelines in different ways and things like that. But you haven't really talked about, okay, what does it actually use for in the end, except dashboards, of course. Could you give a few examples?
Just four.
We have plenty.
Yeah. We have also a pipeline actually reads into our core banking system about the FX rates that is being fed from another system. That is traveling to our data platform and injects into our core banking system. And also we have also some regulatory requirements that is handled in our data platform. And we have a couple of VMs that is where data is packed in a report format and exposed to the regulatory reporter that is requiring the information. And yeah.
It's also these use cases of, for example, the original data platform, if I can call it like that, was built on top of an Oracle database. And we have some use case where we have to parse XML. And there's a very, very big difference between parsing XML inside of Oracle or parsing it in Databricks. And then also once you do it in Oracle, what else are you touching? Because there's it's the same processors, it's the same RAM that's shared by everybody querying the database, so we can really slow down things for a lot of people. So in this case, it just opens up to process a lot more data, a lot faster, and also not be afraid of, maybe afraid is the wrong word, but gives us the opportunity to, if we find a problem in one really big table, because we know it's Databricks, we know how it was built, and it processes data, and we need to process everything, like we need to rebuild the table from scratch, then we can just parallelize the hell out of it, give it as many clusters as my manager would let me use, and then just rebuild the table. Compared to doing it on a regular database, you still have some very strong constraints.
There's another question from online, and that is, what are the future plans for the platform beyond Power BI and so on? For example, enabling scientists to run exploratory analysis and ML development on Databricks or something else?
Yeah, well, the platform is open for everything, but yes, that could be potentially next step.
Do you have kind of concrete people asking in your organization to do exploratory?
Yeah,
can I?
Yeah, you can
go
jump
ahead.
in now. Yeah.
Maybe you can come close to the microphone, which is on the table.
Yes. So I think to understand where we are, we came from a company that started with a big Oracle database, and everything was in the Oracle database. And that's basically kind of what we have a few different initiatives that are moving that out and killing off our old core banking platform. And this is one of them. We have advanced analytics team in-house, which are very focused on, you can say the problem when you're sending money around is to figure out, who are the bad guys and what are the trends. When are we participating in what Danske Bank and Nordea has gotten a lot of flack for? We don't want to end up in the same situation, right? So detecting those few transactions so I think over our history of our company, we've had 200-300 million payments in that order of magnitude, and we have had to report to the authorities, what can be counted on hands and feet. So trying to find those ones, and the further the problem there is that you don't get any feedback. They don't tell you, maybe you can read in the news, but they don't actually tell you this was a good hit or this is a bad hit. So we have a team of advanced analytics that are working internally, and we have basically, kind of from an enterprise architecture angle, as systems split the data platform from data applications that are using it. So we consider the advanced analytics teams as, you can say, a separate team with separate responsibilities. So they can use the data platform, they can drag their things. We sit right next to each other, we talk a lot, we inspire each other, and we share, you can say, quite a bit on the tool stack. So I see Jan quite often talking to Lisa about the Databricks. So they're also interested in that, and we get some synergy from sitting together. But from a system landscape perspective, it is basically separate systems. So I hope that kind of paints a picture of it. And I also work at Banking Circle.
Yeah,
it's probably obvious.
Sorry, now you have your turn.
It's more a question about GDPR, which you probably have to abide by. I was just wondering, if you have customer-sensitive data, do you also encrypt that? And if you have different people in the organization with probably different roles, how do you give them access to the data based on role level?
Are you especially thinking of taking the data to the cloud, or do you?
Taking the data to the cloud, but maybe encrypt it from end to end and then decrypt it only on querying the data or something?
Our lower environments are encrypted, but taking the data to the cloud, that is now approved, and we can do that.
Yeah, so we're regulated by the Luxembourg regulator CSSF, and when they have taken the stance with Microsoft or with all public clouds that you can use public cloud for material purposes as long as it is pre-approved. And they ask, is it encrypted in transit, is it encrypted in the rest? Can the cloud provider scale up and down? Is it an actual cloud you're using? So they have like a 13-page form that you have to fill out for each process. So yes, what is in a payment instruction flowing through the chain? You have accounts, you have names, you have addresses, you have hi mom, thanks for the whatever. So you have that naturally in our transactions that we're dealing with. So the part of the infrastructure that we're using, we are encryption at rest and encryption in transit are important criteria for us to be able to use Azure. any other cloud provider if you want to change that, but that would be a big.
And then access of the data is governed on the report level, not on the.
So as not giving away secrets, but we are considering projects that will mean that we have to enforce a very strict row level security at the moment. And the good part about the pattern with Databricks is that it actually, and especially that's why we're happy with the authentication and impersonation towards the storage, is that it allows us to do row level security. If we had to do it in the old with the Oracle database and Tableau, we would have a access management license. So if we actually take the decision that that business idea we're pursuing, we will only do that with reporting based on Power BI because we don't want to deal with the hassle.
Yes. In the diagram, I saw that for the streaming pipeline, you're using Spark streaming. Was there ever the decision between a micro-batch approach, how it's done in Spark streaming, and an event-based approach, for example, with Apache Flink? And how did you decide between those two approaches?
I can answer this one.
Yeah.
The question was why we decided on Spark streaming instead of Apache, or if we even considered Apache Flink.
Yeah.
And the thing is that we do more with Databricks than just the things that we've shown, the simple data pipelines. We also have some Python logic, or we build some other, like we generate files with pure Python. We don't use just Spark code. And since structured streaming is a really good use or is really good as a pattern for streaming from our perspective, and then we can do a lot with Spark and Databricks. It wasn't really a question of finding another tool like Flink, just because this fits with what we need.
Thank you.
Yeah. So how do you deal with the job failure, and do you miss events? And if you do miss events, how do you just try to patch the job or something like that? So do you miss the data basically? Since it's streaming and all this, it's a kind of a delta architecture, you might be storing already that. So do you face a latency?
So the question was about missing records and if we have any latency and how we deal with failed jobs. Most of the jobs that we have are built idempotent, so we can just rerun them. They will not miss any data. They give the same results when we rerun them. And then what's nice about structured streaming in Spark is that it actually keeps track of how far it got. So if it does fail, then it just looks at the checkpoint folder and then continues from where it left off. And then we also make sure when we do write to our tables, we don't simply insert, but we actually apply merge. So either we do an update or we do an insert. And then if something goes really wrong, and let's say the checkpoint folder doesn't look as we want it to, then we can just load back in time since we know that it looked fine, and then it will just update or insert if there's new records.
Okay. And one question about the testing thing. So are you using the Spark context, or you're using some native collections to test unit testing basically?
Question was about the unit testing, and we're using a lot Spark and some smaller libraries to compare data frames.
And spin up the cluster all that time?
No, we just run it locally, like a local PySpark cluster. But then seems like the questions are slowing down, and then...
And that's very good because the pizza is waiting.
I think there's one more.
Just, as I understand, all the compute resources that you are using are basically Spark jobs on Databricks cluster, either permanent or ephemeral. Is it because the size of data kind of confirms this level of compute power, and we just don't need to use some larger computes like container or scripting container or even function? And if not, if other data sources could come which are not that
data heavy. Oh, your architecture, so and kind of
I'll just give a quick answer because the pizza's ready, and then we can take it in details. The question for the ones online is about how come we're using a lot of compute in Databricks, where there's also other opportunities for like containers or smaller processing. And the quick answer is that we use more than what you see over here. This is our main product. So we also have some Docker containers running in some places and some Python scripts and stuff. So there's more. Yes. Yeah, and then just as a final thing, if you guys think that this is interesting and something that you want to do on a daily basis, get in touch. We're looking for people. Find our LinkedIn's over there. And also thank you, Radu, for helping us organize and hosting us over here, and to Leo Innovation Lab for having us.
Yes, Leo Pharma and Leo Innovation Lab. Yes, super. Thanks, guys.
pizza time.
Food and drinks. If somebody can help, I guess we'll put it on the table here. The ones in the bags are vegetarian, and the ones that don't have, they're not in bags, are meat options.